Hi, I'm Tim Van Milligan from Apogee Components. One of the questions that we get occasionally is how do you mount electronics, such as these items here, in an electronics bay? The electronics bay is a compartment inside the rocket where you house the electronics and run all the wiring and the batteries that control things like dual deployment in a rocket, such as this big rocket over here. In this video, we're going to show you how to mount things like altimeters, timers, beepers, dual deployments, and flight computers, and the Telemetrum GPS unit into an electronics bay. And the heart of it is the sled, which is what you see here. The builder in this video is actually B. Dale Garby, who is the inventor of the Telemetrum. And he has built a lot of electronics bays, and he's got a lot of good tips on how to simplify the construction and to make sure everything works. So the rest of this video, we'll go ahead and let B. Dale instruct us on how to build an electronics bay. So we're mounting the Telemetrum on a sled.
Right.
So first, how'd you position holes on the board?
Well, we started out by figuring out where we wanted to put the Telemetrum board. And the constraints here are that you'd like, if possible, for the UHF antenna here to be as straight as it can be. And fortunately, this eBay that we're building for a very large rocket has lots of space in it, so that's not a problem. If we had to, we could twist this a little bit or bend it some, but anything you do that keeps this from being straight will affect the radio link performance somewhat. Then we just line the board up. We want to make sure we've got a little room down here for being able to get wires into the screw terminals. And then we used a little file here to mark the positions of the holes. And then we have some cute little nylon standoffs we're using today that have a 440 male thread on one end and a 440 female threading on the other end. And they're, I don't know, I guess that's about 3/8 of an inch long. What you want to be careful of when you're mounting this board is that it's far enough up off of your eBay sled, or that there's a notch nearby so that you can actually fit the USB cable into the USB connector. Because that's mounted on the surface mount side of the board, as you can see, the supplied cable that comes from the Telemetrum starter kit is actually a pretty slim connector, but you still want to make sure that you've got the ability to plug that in and take it out. You know, a 1/4 of an inch or so would probably be sufficient. These are nice because they give us plenty of room to get our big fat fingers around the cable and plug it and unplug it. Okay. Yeah. So then we drilled some holes that are the right size for use with a 440 tap. And because we have a nice thick plywood sled substrate here, we can actually tap these to put 440 screws, screw threads into the holes. And this makes for a very convenient way of putting in these standoffs. You could, of course, just drill holes and use standoffs that have a longer tail on them that you can put nuts on the back.
Nuts on the back side? Yeah.
Or you could use long 440 screws and some non-threaded, nylon or metal standoffs. Of course, if you're going to use metal standoffs, you want to be careful about the diameter of them because you don't want to be interfering with things around here. We have in the silk screen on the board, there's some circles drawn that give you an idea of how big around a metal standoff could be before it might cause a problem. These are all sort of standard things that electronics people get concerned about, but I think for a lot of folks building rockets, some of these may be new ideas to think about.
Okay, and then once you get the nylon standoffs, how are they held in there besides the threads? Would you put super glue on the threads?
Normally I often use a dab of 5-minute epoxy. Super glue or something would work as well. Because this is a nice thick sled made out of some good quality plywood, they might be fine just threaded in like this. But again, it's nice if the standoffs don't turn when you're trying to put screws in and out of them, and so I would usually put a drop of some kind of an adhesive. And again, if you were using metal standoffs, they might go through and have a lock washer and a nut on the back or something like that. Okay. But modular, whether we decide to put some glue on or not, the next thing we would do is just mount the board on those standoffs with some screws.
Where does a user get these standoffs and the hardware to mount all this?
We actually buy these from Small Parts, who ship through Amazon, and I have not done so yet, but we've considered making these available through our website or having them be part of the starter kits. We are still thinking about how much of this sort of stuff. You know, everybody's eBays are different, and people have different opinions about the best way to mount things, and so there's kind of a trade-off here. This is one way that we like, with these little nylon screws and standoffs, and this seems to work really well. But you know, as I said, other people sometimes have other opinions about it. If you take a bunch of rocket folks and all line them up, you probably will have as many different ideas about how to do an eBay as you have people there. There we go. And the holes in the board here are sized to work reasonably well with like a 440 screw, or I guess it's a metric M3 for people in places where those are easier to come by. So they're all snugged up, and there's the board mounted. Now the next thing I would typically do is gently bend this antenna wire down so that it's flush with the board, and then we'll probably put a piece of masking tape over this to hold it and keep it from flopping around during flight.
Okay.
Then I guess the only other really significant thing we have to do is to mount the battery, and a lot of times what I like to do is mount that on the back side, sort of underneath where the electronics board is. And to do that, one of my favorite ways to do it, so as you can see, that would mount reasonably well. Put a hole in here to bring the cable up through to plug into the power connector, and we'd have sufficient length there. One of my favorite ways to mount these batteries is to drill 2 pairs of holes and wrap them with nylon cable ties. I have some of those with me. And then sometimes we'll even wrap this with a little bit of closed cell foam or something to cushion it. Lithium polymer batteries are reasonably robust and safe, but because they're very high energy density, you'd prefer not to puncture one. And so a lot of times we'll put a little bit of extra foam on them when we're mounting them, just to make sure that they're simultaneously snug but protected. So let's, as you can see, we can see where the holes are from the telemetrum board, and we can take a pencil and just sort of line the battery up crossways and mark a couple of lines here as to where the battery edges are. And then actually a lot of times what I'll do is use this to get a reasonable spacing for a couple sets of ties. Never measure when you can mark, right? And the nice thing is that puts these holes outside the space that's occupied by the electronics board itself, so we're in no danger of drilling into it. We could, of course, always take the board off while we're drilling these holes too. Or if we're really, really smart, we might drill them ahead of time. Okay, so where'd your Dremel end up?
Okay.
And actually, just because I don't want to hurt anything, I will pull this off while we're doing this.
What size drill bit do you want for this?
Here's an 1/8, I think, here. That other collet that was here should work fine, I think. That looked like it was an 1/8 inch collet. Yep, that looks pretty good. And then we need one more hole to bring the cable through from the battery. And we'd like that to be convenient to plugging it into the battery connector here. So I'm just going to eyeball, and we'll put it somewhere here, sort of adjacent to the board, not too close to the other holes, and just to the side of where the battery is. So we'll drill a hole for that. And we probably actually need to make that larger. Do you have a 1/4-inch bit? All the things you don't think about.
It's going to take forever to try to drill through that.
I can probably do it pretty quickly if you want. It's all a matter of attitude. Here. Okay, maybe not the prettiest 1/4-inch hole ever drilled. But there we go, there's a hole big enough, and the trick here is we wanted it to be big enough that we can feed the lithium polymer batteries connector through, and that works beautifully. Now while you're refining the drill bit, I cut a little piece of closed cell foam. This is packing foam, various things come wrapped in it. This is optional, but again, I like to do this. And so we wrap it in some foam. And we'll put that down there. And then we need some zip ties. Here's a little small diameter nylon ties. As I mentioned, there's lots of ways to mount these things, but this happens to be one of my favorites. And of course, because these are short ones, I'll end up using 3 of them per side to wrap around and hold this battery in place. But I normally buy these in big bags. Using a few of them is no big deal. And again, this foam just provides a little bit of extra protection for that battery, since the lithium polymer is pretty high energy density. Giving it a little bit of extra shock protection seems like a good plan. Though we've never actually had a problem with one. So again, nothing fancy here. I'm just end-to-ending some small gauge nylon wire ties. And you'll notice that again I've mounted the battery crossways to the direction of flight. Rockets don't tend to take a lot of shocks sideways, but there is quite a bit of acceleration along the rocket's axis. And so in my experience, 2 straps like this, if you're mounting the battery crossways to the direction of flight like this, is sufficient. If you expect lots of side-to-side motion or shocks, then you might want to put another one the other way, but I don't think we need to here. Also, because this is mounted between the brass tubes that are part of your eBay design, that sort of guarantees it's not going to go very far, even if it does move. And so now, just cut off the tails on all of those nylon ties. Clean it up a little bit here. And And there we are. We have the battery nicely mounted to the sled. It's very snug. It's not going to go anywhere. And I did take the board off while we were drilling holes and messing with it. So we can mount this back on. Okay, so I've got that mounted back. Screws back in there, moderately snug. And plug the battery cable in. And the hard part's done. Okay, so then the next thing we need to be able to turn it on at all is some kind of switch. There are two kinds of switches that we like a lot. One kind are these push-on, push-off switches. This little miniature push-on, push-off switch made by C&K, I think. Yep, that's a C&K switch, and these are pretty good switches. They have a very sort of solid push-on, push-off action. If we mount those again so that they're sideways to the direction of flight, we can solder a couple wires onto them and hook them in here. That can be very effective. You can also mount this on your sled near an edge or something and put it right behind where the static vent hole in the eBay would be, so that you can reach in from the outside with a little screwdriver or something to push that to turn it on and off. And so that's one way you can do this. Another kind of switch that we like a lot is a rotary switch. These are actually originally made to be 110, 220 volt power selector switches. And these are designed to be operated with a screwdriver. As you can see, they have a very robust snapping action as well. And a lot of times we've seen folks mount these through a hole in the airframe. And it's actually possible, depending on your eBay design, to recess these. You can make a 5/8 inch hole to recess the top part in, and then a 1/2 inch hole for the rest of the threaded part. And you can actually mount them so that they're flush with the airframe. That's a lot of fiddly mechanical work, but it makes for a really clean installation. What I have today for us to play with is somewhere in here. I actually took one of the push switches and I've already put 2 wire leads on it, soldering those on. As you can see, I've actually soldered across. This is a double pole switch, so I've actually soldered across both poles, so we get a little redundancy from having both poles of the switch being used to turn it on and off. And then all we need to do is screw this into the switch terminals. Get my screwdriver here. These 2 terminals are the ones for the power switch.
Those are the 2 ones closest to me.
They're actually labeled on the board as switch. If I remember, it's switch main and apogee. And the silkscreen writing is all fairly small. It's the curse of doing really small boards like this, is there's not a whole lot of space for putting text in the board itself. So I just put those leads in and snug them up. And now if we turn this on, the board ought to come on. That's 3 beeps. That's a Morse code S for startup. And 2 beeps is in Morse code I for idle mode, and that little chirp tells us there are no ejection charges attached. We'd get 1 beep, or 2 beeps, or 3 beeps for one, the other, or both of those charges attached. Okay, well at this point we can figure out where you want to mount this switch and how you'd like to vent it, and you'd be all set. Given the geometry of this eBay and the fact you probably want your static port up here, we might actually need longer wires. I wasn't thinking about that, but this switch isn't going to mount high enough to match where you're.
Okay.
So if you see, this goes more or less in the center of there. We have to get up if we want to just be able to reach a push switch through your static vent hole. First of all, that static vent hole probably needs to be a little larger for this big of an eBay. But then we would actually have to have a switch that reaches farther. Or as I said, alternatively, we could mount a rotary switch through the wall and put leads on that are long enough to reach either.
Okay.
So this is where the sort of decisions part comes in.
So you see I drilled out the hole, made it 1/4 inch.
Yep, that should probably be okay. There are actually calculators, as you know, for working it out for a given eBay volume. We can check that later. I think a 1/4 inch is going to be pretty good though. So then the next thing we want to do, I think, is to mark the edge of this sled so that we know where that hole is. So what we'll do is put this together, and then is this directional or does it matter?
Doesn't matter.
Okay. So what we want to do is assemble the eBay and do it so that the edge of that board, the edge of the sled's right behind the hole, which will make it easy for us to mark where that switch needs to be. So the idea here is we're going to put a push button switch mounted so that we can reach that switch through the static vent port. And so now once again, we need to mark that. This will probably work. I'm just trying to put a little nick in the edge of the sled. Let's see if that's enough to see. Yeah, I think so. Right there. So I will and then from the measure twice, cut once philosophy, I'll put it back together and see whether we can actually see that mark in the right place. And if so, that'll be our reference mark for mounting the switch. And oh, I see I had it pushed down too far, so actually I'm not sure what I'm doing wrong. Oh, there we go. A lot of times when I'm building eBays, I'll actually put nuts on both sides of the bulkhead that's the fixed one. I don't know that it's a big deal here, particularly with these huge pieces of all thread, but a lot of times that'll allow the eBay contents to sort of come out in one piece, which can be convenient when you're prepping. Now I need to rotate this a little bit because, oh yeah, I can see it. I don't know if you can see it, but we've got that black line is right there. Okay. And it looks pretty centered to me.
Okay.
So that's a good reference mark for this. So now this particular sled, if we look at it, this sled has a lot of slack space around it inside there.
Mm-hmm.
So it wouldn't matter if the switch were hanging off the side of it a little bit. Yep. The only concern you'd have if it's hanging off is that when you're handling it out on the table, you might bump the switch and break it. A lot of times when we're making eBays, the sled ends up being a snugger fit, and so it's really important to have that switch not hanging over where it would interfere with the airframe. But as I said, in this case, it's sort of a don't care. So what we want to do is I'll just carry that mark around to the face here so that we can see it easily. What we want to do is mount the switch so that its center line is on that mark, and then reaching in through that hole we'll be able to do the push on, push off of that switch with a little screwdriver or something. As we mentioned, yesterday, there's lots of different ways to mount switches. It's actually possible to use one of the rotary switches in the same kind of configuration where you stick it down on the sled, put a zip tie over it through a couple holes, and then smear some epoxy around to hold it. The exact type of switch isn't all that important, but these seem to work pretty well for me. So at this point, what we need is some adhesive to stick that down with, Tim. And I brought a clamp along to make it easy to hold it while the glue sets. Excellent. So I've never used one of these.
You just knead it together and then you snip the end and more like a
I see.
This is a Reactor Pack.